Hello everyone, my name is Jacob Buell and this lab is about the motion of the falling objects for the class of Physics 2211. So, as an introduction to this lab, the aim of this lab experiment is to discover how an object behaves when it is dropped from rest. So some of the main objectives are to determine if we can find an object's terminal velocity and honestly understand what that is, and to determine if terminal velocity is affected by its initial velocity. Here's pictures of Isaac Newton. So, going on from Newton's second law, this is some context that we need to understand before we get into this lab. So Newton's second law of motion states that the net force is the change in momentum over time. And it can be written as F net equals ma, or as what I said previously, momentum over time, which is mv over dt. So we also need to understand the drag equation. So when objects fall in our atmosphere, they encounter drag, which is also known as air resistance, and it's what makes a flat sheet of paper fall a lot slower than a rock. So this circumstance can be written by the equation F drag equals to negative b times b squared times the unit vector of the velocity. Now, in this equation, b is a proportional constant. So depending on what object is falling, for example, it'll be different for like a rock or a sheet of paper. And the v, of course, is the object's velocity, and then v hat is its unit vector. So in this lab, we have the system and surroundings. So the system in this experiment is the crumpled sheet of paper that I'm about to explain. And the surroundings would be everything else. So in this lab, I recorded the motion of a crumpled up piece of paper falling from zero velocity. So it's in my hand and I'm dropping it without creating any initial velocity like I'm throwing it down. It's just straight dropping out of my hand. I used tracker software to track the position of the piece of paper at constant time intervals. I also created a computational model of the theoretical position versus time using GlowScript code with and without drag, air resistance. And this is done by changing that B proportional constant value that I explained earlier in the drag equation. So I also compared the data from the simulated models and the tracked real-world data. And I got a drag constant value of 0.277 for that B value in the drag GlowScript code. So here you can see the code on the left, which has the B value at 2.77, and the code on the right, which has the B value at 0. So the code on the right side is when you are not including the force of drag. So you just have the net force equal to the force of gravity going down. Well, on the left side, you can see F net equals the gravity plus the drag equation, and which this will be in the opposite direction of the unit vector. So in this graph, the blue graph is the simulated GlowScript code, not including the drag equation. So you can see it simulates the object as falling a lot lower than it actually did. And the real world data is the red line. So you can see how the object is accelerating downward, but not nearly as much as the blue line, because there is in real life, there's a drag force pushing upward. And this is correlated from the drag equation simulated in the GlowScript code, which is shown in the orange line. So, in conclusion, the data from the GlowScript model coincides closely with the tracker real-world data when looking at the simulated model using the drag equation. Now, what does it mean? The simulated GlowScript model with the drag equation lets us understand that the velocity of the paper ball could and will eventually reach terminal velocity because the force of drag was continuing to increase. This means that when the paper ball reaches terminal velocity, the net force will be 0. Now, what if? Alright, even if the ball was initially thrown downward, with the initial velocity, we can know that the terminal velocity would still be the same because the force of drag, not draw, is with respect to velocity at each moment, not just the initial velocity. So the only change that this causes is the object would reach terminal velocity sooner.